Welcome. Today we will cover moment of inertia of a rectangular area or structurally, rather, see, from structural engineering point of view, you can write rectangular cross section. Actually, it is rectangular cross section. But here in engineering mechanics we call area, okay, or lamina. But in structural engineering it is rectangular cross section of a structural member. You can write. Before that, I already told basic principle of moment of inertia, and then I explained thoroughly how to feel moment of inertia and how to understand moment of inertia, how mental feeling will come. One long class uploaded, class number 41. I told those who are interested, go through it. Lecture number 40 required. 41 is lengthy class for those who are interested, but actually everybody should go through it. 42 last time I proved two important theorems, stated and proved parallel axis theorem and perpendicular axis theorem. That those two theorems, among those two theorems, parallel axis theorem is widely used. I told 99%. Perpendicular axis theorem we will use only limited number of times. Very rarely we will use it. So, once I finish everything, all these basic derivations, what I will do is one exclusive class will be there for application of parallel axis theorem. Very lengthy class, maybe around 2 hours, more than 2 hours. So, because it is very, very important how to use parallel axis theorem to find moment of inertia of a cross section. That is everywhere required in structural engineering. Now, apart from that one, there are some more terms are there. See, one called polar moment of inertia. Moment of inertia of an area about an axis passing to any point in the plane perpendicular to the plane of the area. That is what I told last time, IOZ. Okay. And then another term called radius of gyration. Very powerful term in structural engineering, especially when buckling of column is considered. When stability of column is considered, the term radius of gyration is very, very important. And also one more term called product of inertia. Product of inertia, generally we don't require it. It is required only for unsymmetrical bending or when warping comes. Okay, leave it now. So unsymmetrical bending. So polar moment of not product of inertia, I will take it late or I may not take it here. Usually nobody will solve problem here for product of inertia. When the time comes, I will explain at that time. And radius of gyration, what I will do is a very thorough concept of that one will be given for you. After deriving, I decided first. See, otherwise, complete only theory, people get bored. So let us go to standard cases now. Then after all the standard cases are over, we are going for numericals. When I start numericals, before that, I will thoroughly explain radius of gyration very thoroughly. Maybe some example I will give, and I will make it crystal clear. The way you feel moment of inertia, same way you should feel radius of gyration. And product of inertia and polar moment of inertia, that class, somewhere I will mention it. Okay, now we will start basic derivation. I decided, first I thought today I will do that radius of gyration and other terms. Then I decided, no, only theory is somewhat little boring. So better go to requirement. So moment of inertia of a rectangular area, structural engineering, rectangular cross section. See, consider rectangular area B by D. Now, little late you write class. Usually B we call width or breadth. D we call depth. But sometime remember, if the bending is about this axis, then B is the breadth, D is the depth. But if the bending is about this axis, then what we call B here, that become depth, structural depth. See, there is one term called B by D is general, simple language. I will use one word later called structural B and structural D. Structural B is always parallel to the axis of bending. Structural D is always parallel to the is always perpendicular to axis of bending. If bending is about x-axis, Structural B is this B only, structural depth is D. But if the bending is about this axis, how you don't worry now. Then structural B is depth D. This is what you call D here. Structural depth will be B. That all I will tell later in the structural engineering subjects. So right now, don't worry too much. Rectangular area B by D. See, some class, I will dictate something. The most popular way is B you call breadth horizontally, D you call depth. Some people use capital D, I use small d. Because if I use capital D, all these years, for more than 40 years, I use small d. I write capital D here. Later, I will change it to small d. No, D. In RCC, I will use capital D because small d is for effective depth. That you worry at that time. So, this is a rectangular area. Now, let G be the centroid. See, centroid is here, G. See, if this is B, B by 2, B by 2. If this is D, D by 2, D by 2. Everybody knows it. I don't have to explain now. Already proved earlier. Not proved earlier, we decided earlier. Okay, then. Let XX and YY be centroidal axis. Axis, because two are there. Axis, as shown. Now, class. B usually we call width or breadth. Usual term. D we call depth. Okay, then, because when you look here, see, this is a width and this is a depth. Too much worry we will do when you go to structural engineering. This is structural engineering only, that is strength of materials and more subject, RCC, steel, where I will consider more. Then, XX is horizontal, you see, I am not writing everything, space is not there. Make one more note. When I call XX, is a horizontal centroidal axis. You should write here, horizontal centroidal axis, or it is parallel to B. See, if B is here, parallel to B is horizontal centroidal axis XX. Same way YY is vertical centroidal axis, parallel to D. Write note. Now, then, once again class. Class means I am dictating something, you have to write it. The most important term is moment of inertia about XX and YY. That is called moment of inertia about centroidal axis, XX and YY. Now, again class. See, when you go for moment of inertia calculation later for I section or any section where components are there, we always require first moment of inertia about centroidal axis. But class, so see, I should tell, sometime in competitive examinations all, see, structurally we don't consider it. We don't consider. We should write here. But in competitive examinations, especially, they will ask, what is moment of inertia about the base? See, say AB, you write here. What all I tell about the base, say AB, or about the top edge, say CD. I will put here CD, some name, CD. Or they can ask, what is moment of inertia about the left vertical edge, say PQ, or right vertical edge, say RS. After A, B, C, D, you get EF. I skipped it because after EF, GH will come. G is for centroid. Next, IJ will come. IJ means I is for moment of inertia. So I decided to change it to PQ and RS. Okay, then that also we will get it. This also we will get in this class. But remember, make a note, this has no further application. We will not consider this I about AB or CD or PQ or RS when we consider moment of inertia calculation later using parallaxis theorem. We will not use it. So purpose is only, right, competitive examination or academic examinations. From structural point of view, you require only IXX and IYY. First, so I will do one thing now. This everything I will remove. Now I will start moment of inertia about, I will get the expression for I about XX, I about YY. Now, Almost everybody knows the answer. I about xx. B into d cube divided by 12. I about yy. D into b cube divided by 12. Or I about AB or CD will be b into d cube by 3. Same way, I about PQ or I about RS will be d into b cube by 3. But remember that db cube or bd cube by 3 is of no use for us. It is only for academic purpose or academic examinations. But this bd cube by 12 I told is most powerful. That you will get it now. Now before that one I will remove everything now. This all note I told you write systematically so that everything is clear. See, I will tell one more thing. This subject I am taking very systematically. Nothing I am skipping. And I will give explanation for each and everything. Like how I made you clear the concept of moment of inertia, how to understand what actually is moment of inertia and how to feel it. Same way, I will later, I will make you, I will see that you get the same thing, that is understand and feel that radius of gyration also. And when you get moment of inertia equation, what answer you get, again feeling will come there. I will tell little later. Okay, now full I will remove. My next heading is moment of inertia of a rectangular area about centroidal axis or axis. See, okay, I will make ready now. Start now. I wrote everything earlier because this is very simple. I want to save the time. If some concepts are there, then sometimes I will write in front of you so that you will understand. So you will be involved. Here nothing is there. Some principle is there. I will tell. See, moment of inertia of a rectangular area about centroidal axis, that is IXX and IYY. Right here. Already I have marked a section and shown you XXYY. Again I won't write. So start. Consider I about xx, b, d. This is d by 2, this is d by 2. This is centroid G. This is a sketch. Now, what to do is consider elemental strip of thickness dy at y from xx axis. See, at y from xx axis, because when you do horizontal, when you consider horizontal axis, distance is vertical, variable is y. When y is the variable, thickness should be dy, as shown in figure. Okay. Let dA be area of elemental strip. See, this area equal to dA. Now, therefore, dA, area of elemental strip equal to b into dy, width into thickness of the strip. Then, this I won't tell. I told very clearly, by basic definition, moment of inertia, Ixx, remember, for the entire rectangle, if you want moment of inertia but only of the elemental strip, it is dA into y square. But when I have not written any elemental strip here, say by basic definition, moment of inertia of entire rectangle, not required, rectangle, that is I about xx equal to integration of dA into y square. Actually, I told earlier, either sigma or integration. See, but here, since when you are taking elemental thickness dy, etc., you have to go for integration. Integration of dA into y square. Okay, up to here, right here. Then stop. Stop 1 minute. Stop. Class. There are two options for you. Option 1. See, option 1. What you do is, see y. See, here I simply wrote d by 2, this only distance I marked. But here, see, when my y goes this way, I have shown arrow mark here. See, this y can go above xx up to d by 2. And also, y can come down below by d by 2. See, from here, if you consider strips anywhere above xx, your y varies from 0 to d by 2. Whereas if you take y this way, it varies from what? 0 to d by 2. Or if you consider entire rectangle, mathematics actually, when you took y this way, the limit can be, see, we want to rectangle start from here to here. So therefore, starting from here y equal to minus d by 2, because we are taking y above the xx. This is below. So it is y equal to minus d by 2 to y equal to plus d by 2. See, if you take minus, see, y equal to minus d by 2 means here. From here to here, rectangle. This full rectangle you want to cover. So your y lower limit is minus d by 2 to upper limit plus d by 2, because your y is from xx. Okay. This should be clear under normal mathematical knowledge. So equal to b into b constant, y square dy will become y cube by 3 minus d by 2 to plus d by 2. Substitute b into y cube by 3 plus d by 2 cube divided by 3 minus of minus, see, this is mathematical minus, integration, minus of minus d by 2 cube divided by 3, or b by 3 common, d cube by 8. See, 3 I had already taken outside. 2 cube is 8. D cube by 8 minus again minus d by 2 cube. Minus d by 2 cube is minus d cube by 8. Why? When negative term is there, square is positive, cube is negative. Minus d cube by 8, or it is b by 3 into d cube by 8 minus of minus d cube by 8 is d cube by 8 plus d cube by 8, that much not required, or equal to, okay, equal to b by 3 of, okay, d cube by 8 plus d cube by 8, or equal to b by 3 of 2d cube by 8. Now 8 into 3, 24. 2 divided by 24 is 12, or equal to bd cube divided by 12 is the answer for I about xx. This is option 1. I will give you second option now. Both are same. See, here second option. See, option 2 I will write here now. This sketch will remain same. Option 2. Something I will tell in the class now. You should write it. Option 2. I already wrote Ixx equal to integration of dA into y square. Class. Option 2. Consider only area above xx. Above xx. Then above xx for integration. Only area above. Don't see this side. See only that side. Therefore, your Ixx will become, see, Ixx will become for the entire rectangle equal to dA into y square. What is dA? Integration of dA is here. B into dy into y square. You consider only, you write there, from xx up to extreme fiber. How much? Y equal to 0 to y equal to plus d by 2, no plus minus, y equal to d by 2, no sign required now, y equal to d by 2. Now very important, right, this will give moment of inertia of the rectangular area above xx axis. But their same area is there below xx axis. Therefore, whatever you get there, multiply by 2. That's all. See, you do only for half the portion. Integrate from 0 to d by 2. You will get moment of inertia. You write here. This will give you moment of inertia of the area which lies above xx That is for a width for b into d by 2. But same answer below, multiply by 2. But someone may tell, sir, below negative is there. No, even if negative is there, what happens? Moment of inertia is, see, if you take here dA into y, if you take y this way now, if you take y this way, dA into y square is there. If you take y this way, where is from 0 to d by 2 only. So into 2. This also will do, or equal to b into y square becomes y cube by 3, limit 0 to d by 2 multiplied by 2, or it is b, see, multiplied by 2 equal to b into d by 2 cube divided by 3 minus lower limit 0 multiplied by 2 equal to 2 into 2 is, see, or b into d cube by 2 into 2, 4 into 8, 8 into 3 is 24 multiplied by 2, or equal to bd cube divided by 12. Once again, same answer. But technically, the first one is correct. Better first one. This also will do. Sometimes you have to use this way for, because when to save the time, when identical is there, you do for one side, multiply by 2. Someone may tell, sir, this side y is negative. No, when you do this side, your y is like this. So 0 to d by 2 once again, identical. So bd cube by 12 is I about xx for rectangular section. Now, I will write the result for you. See, therefore, 1 minute now. Result. See. Therefore, see, for a rectangular section, see, I have to brief result because later full summary I am writing. B, if this is D, this is your xx axis. Xx axis. This is d by 2. See, no arrow mark now. d by 2 and d by 2. This is centroid G. Axis is xx axis. You can write Ixx equal to b into d cube divided by 12. Or in words I will tell, in words, side parallel to axis. See, side parallel to axis means here xx axis. See, side parallel to axis multiplied by cube of side perpendicular to axis. Axis considered. See, B, side parallel to axis multiplied by cube of side perpendicular to axis. This is I about xx. Now see, you need not waste time deriving I for yy. See. Similarly, you can write here. Similarly, if I turn here, again it becomes rectangle only. Similarly, direct answer. See, if this is the axis B, if this is B, this is D, this is your YY, centroidal axis, vertical centroidal axis, YY. Now, this is centroid G. See, this will be B by 2, this will be B by 2. You can write similarly, okay, similarly, I about YY equal to D into B cube divided by 12. That is once again what? Once again side parallel to axis. See, axis means now YY axis. See, side parallel to axis here into cube of side perpendicular axis. Oh, I forgot. Divide by 12. Last time, I think I forgot write divide by 12. If I have not written, write it now. Just now I rubbed it. I wrote the statement there. See, I wrote the statement little earlier. Side parallel to axis into cube of the perpendicular side by 12. Actually, maybe I forgot to write because divide by 12 is there. Don't make an issue of, don't put in a comment. No, you forgot to divide by 12. I will tell, don't attend my classes. If such things, I told I forgot. If I forgotten that one, you previous also, you write divide by 12. Okay. Right here. This is the answer. Or, see, actually not required, over. Okay. Or, see, or those who want can do this way also. See here. Those who want can do by integration also. Actually, waste of time. See here. This is y axis. See correctly now what I am doing to understand. This is, see, this side and this side is b by 2 and b by 2. Arrow marks are there. This is b. I write somewhere here. Actually not required, just to understand only. This is b, this is d. What you do? Take a elemental strip here. Take elemental strip here, parallel to yy. See. Now distance should be not y, it is x distance now, at distance x from here. X. Let the thickness equal to dx. Area equal to dA. Right here. Elemental area dA equal to d into x is d into x. D into x. This is not d, mathematical dx actually. D is depth d. See, d into x. Therefore, I about yy is, for the entire rectangle, is integration of your dA, blue green color. See, integration of dA into what? dA into x square into x square. X varies from option 1. See, option 1. Option 1 is, see, when you take x this way, varies from minus b by 2 to plus b by 2. Substitute, you will get the answer d into b cube divided by 12. Or option 2, I about yy equal to integration of dA into x square, dA into x square. See, you do only one side. Integrate from 0 to b by 2. 0 to b by 2. See, 0 to b by 2. But whatever you got, multiply by 2 to care of this side. This also will give you dB cube by 12. dB cube by 12 is the answer. Not required. Right. Now, right, lastly, therefore, final answer I will give, final result. See, therefore, I will put result. Very, very important, result. I told any result connected with centroidal axis are very, very important. Make a note here. See, if I write other result, I will use black color. See, make a note here. Any result connected with centroidal axis is very, very important. So the result is that you write here, if there is a rectangular section, say any one side, let one side be B. Okay, anywhere you write B here. We will call B is the breadth. Other side is D. Depth. Usually we call breadth and depth. Mark centroid, G. Draw an axis passing to centroid and parallel to B. Horizontal is there, call XX. So this distance is D by 2. This also is D by 2. Same way, draw an axis through centroid, vertically yy. This is b by 2 and this also is b by 2. Now write here, you can write here the d, okay, I'll do one thing, d I'll write here. To understand, I'll put d here. Now write here, I about xx equal to, if you want about xx, parallel side b into perpendicular side d cube divided by 12. Okay, red color. Okay. IXX red color. Answer is black color only. And if you want I about YY equal to, see, if you want about YY, then parallel side is d into b cube by 12. This right here, these above 2, we will use repeatedly later in entire structure engineering. This is the moment of inertia for rectangular area or rectangular cross section about centroidal axis. Okay, now little more is there. I'll start. See, we completed moment of inertia for rectangular section or rectangular area about centroidal axis. That is the most important. I wrote the result in red color that we are carrying forward. Now, additional information class only for competitive examinations or academic examinations. Otherwise, it has no application. See, class, consider width B and depth D, B by D. One axis you take to bottom edge, AB, also called as base. Some people I about AB, or some people tell I about base. Okay, both are same. Some people use the word base is more clear for everybody. It's color confusion for me. It's always there when multiple colors are there. Or I about base. I about base. Say AB. See, I will take about AB. Moment of inertia about the base for rectangular area AB. See now, what to do? Statement you will write. Consider elemental strip of thickness. See, you are doing y this way of thickness dy of thickness dy, comma, at y from AB. I am not using red color now, y from AB. Let dA be area of, you write, area of elemental strip. So 100% dA equal to B into dy. This is same as last time, B into dy. Therefore, I about base, I about AB is integration of your dA into y square. This all told 1000 times y square is the answer, or equal to integration of dA, B into dy. Okay, this is a green color. Integration of B into dy into y square. Limit is, now see, your y is from base here. Now, earlier last time, see, if you remember, last time it was once d by 2 plus 2 minus d by 2 or 0 to d by 2 into 2. Now it is not that way. Here to here is 0 to what? D. 0 to d, or equal to b into y square will become y cube by 3 from 0 to d, or equal to b into upper limit d cube by 3 minus 0, or equal to bd cube by 3. bd cube by 3. Or once again you can make a note here. Side parallel to the axis into perpendicular side cube divided by 3, not 2. But this has no application. Now, this is one of the options, same way IAB over. Okay, now, instead of wasting time more, there is another option. See here. There is another option, which is actually correct option. Moment to get IAB about the base for rectangle. See here. This is using parallel axis theorem. Parallel axis theorem. Okay, do one thing. Consider the rectangle. Consider rectangle here. This is B. This full is D. This is your axis AB, about which we want moment of inertia. See, what you do is, first mark centroid. See, centroid is here, G. Mark an axis passing through centroid parallel to AB, that is this axis, x-axis. And now, this distance will be what? D by 2. That everybody knows. Now, by parallel axis theorem, remember, you can make a note here. Anybody who is getting a little confused, little later, very thorough explanation is there. So, you go there, study and come back. I about any axis, see, I about AB equal to IG plus AH square. IG plus AH square. This I proved last time. IG into A into H square, where H is the perpendicular. See, H is perpendicular distance from centroid to required axis. Therefore, your H will be equal to D by 2. It will be equal to D by 2. And IG is moment of inertia about axis passing through centroid, and parallel to, passing to centroid, see, red color, and parallel to required axis AB. That is nothing but your I about XX. We know that I about XX standard case is BD cube by 12. Already proved just now. BD cube by 12. See, this everybody knows. Therefore, your I about AB equal to IG, that is BD cube by 12, IG plus area is B into D. I don't have to explain what is area of rectangle, B into D, into perpendicular distance from centroid to the required axis. This distance square is D by 2 square, or equal to, if I take BD cube outside, it is 1 by 12 plus BD into D square is D cube. 2 square is 4, 1 by 4. Or it is BD cube by 12 into 12, 1 plus 4, 3 times, 4 plus 3. Or BD cube by 12 into 4, or equal to BD cube by 3. That is same answer we got just now. Okay, now that's all. Therefore, write the final result now. See, final answer. Remember, same way you can make a note. If you want I about CD, same procedure, take Y from top. If I want I about PQ, take X this way. If I want I about RS, take X this way, not required. Or, see, therefore, additional information, see, additional information for competitive examination or academic examination, you write examination, is moment of inertia I of a rectangle about base or top edge or left vertical edge or right vertical edge is equal to side parallel to axis into cube of side perpendicular to axis divided by 3. Put this way, side parallel to axis into side perpendicular to axis divided by 3. This is not standard case. Write this way. Therefore, write the final answer. See, directly, without any ABC. See, if there is a rectangle here, see, if rectangle is here, if this is width B, suppose you take B and this you take D, then see, I about this axis equal to side parallel B into perpendicular side D cube divided by 3. Same way, if you want I about this axis, see here, about this axis I, again side parallel, once again B into D cube divided by 3 for either top edge or bottom edge. Whereas if you want I about this axis, then if you want here, side parallel is D now, D into B cube by 3. Same way, I about this axis is also, this axis also I equal to D into B cube by 3. Remember, this we are using only for competitive examination or academic purpose. Later, structural engineering, we always take BD cube by, because we require moment of inertia about centroidal axis. Remember, so that centroidal axis I told just now, see, these two, XX, YY, this is the most important. That result I will give. When I go to result later, this I will not give. You should make a note this one. See what I told here now, you should make a note somewhere outside. Because when I go to standard case, I will not mention this one. Why? This is not a standard case. Moment of inertia you require about the centroidal axis. Okay, now I will wind up the class. That's the reason. Little more I will turn. Next I am going for a triangle. See, rectangle is very simple. Triangle, little more work is there. In triangle, I have to cover some 1, 2, 3, 4 types I have to solve. I have to solve some around 3-4 cases. So therefore, I want all the 4 cases in one single class. So because title will be, today title is what? Moment of inertia for a rectangular section. See, now I will use more and more word section. Okay. Next class I will go for moment of inertia for a triangular section. Once triangle is over, I will cover circular section, then semicircular section and quadrant of a circle. Once that is over, I will thoroughly explain parallax theorem once again, and also I will give information and details of radius of gyration also, and those two missing, polar moment of inertia and product of inertia, briefly, not much application in our class. Then marathon problems like centroid. No problems with all the questions we solved by centroid. I will go to moment of inertia, and also all those exercises given, plenty of exercise given. For that, in the class, I will write expression, but as an exercise. Okay, we'll meet in the next class. Thank you.